Hi guys, welcome to the next part of DC theorem. So we are solving problems based on DC theorems. I think in the last class, I hope we have been solved problems based on Thevenin's theorem, and we have seen some basic models, and we have seen how to approach those questions, right? So now today class we will just continue with the same Thevenin's theorem. But in the last class you might have seen whatever the questions that we have solved in the last class. All those questions are relevant to only independent sources. So now the question is, when we have dependent sources in the circuit, how to solve those questions? That is the question mark, right? So let us see how to solve the problems when the given circuit is having both dependent and independent sources, right? So let us keep our attention. Let me bring some questions here. So should try to solve it by yourself, right? So now the question is, let me take as usual one dependent source, and then I'm connecting it with a resistor R. Then here I'm connecting one dependent source on independent source on dependent source. And let us take this is a voltage source, and its value is, let me take some 2 times of Vx, and given it is same voltage will be dropped here also, they told like that. And observe the polarity, that is very important, right? So this is Vx, they told like that. Okay, let me do one thing, because the voltage source is connected in this side, to avoid the confusion I will reverse the polarity. Let us take this one is plus, this one is minus. And here I am connecting some reasonable voltage, 10 voltage, plus minus. So let us connect one more resistor in the circuit. Then I am closing it with our beautiful load resistance. Okay, sorry. So now given it is, this is load resistance. Now the question is, calculate VTH and RTH for the given circuit. That is the question mark. Sir, how to solve this question? The procedure. Let us take. Actually, whenever we are trying to solve the problems based on Thevenin's theorem, when it has both dependent and independent sources, what we must do, we should focus on something in which we have to focus. Step number 1. Let us take the procedure to calculate the value of VTH. As usual, how will you calculate the VTH? The first step is identify the load resistance. Where is the load resistance? This is the load resistance. The second step is go to its terminals. Go to its terminals. Then remove the load resistance from the load terminals. So let me name them X and Y. So after identifying the load resistance, we have to remove that load from the circuit. Right. So what I am doing now, I am going to remove this load. So I am taking here, sir, I am just removing this load. Yes. Load is removed. Step number 3. The next step is we have to identify on it. Let us take 2 ohm 2. We have to identify the value of VTH across this X and Y terminal. So we know this VTH is also called open circuit voltage. Let us calculate this value from here. Now what my question is, since it is open circuit, then what is the current through this line? Anyone? So this is 0 ampere. Why it is 0 ampere? Why? Because the open circuit between the terminal X and Y, we are having a open port. So open port will offer always the resistance offered by the open circuit is infinity. When the resistance will approach infinity, automatically current I will be inversely proportional to resistance. Since resistance is approaching infinity, so current has to approach 0 ampere. So the conclusion is the current through this branch is 0 ampere. Now my question is, then what is the value of the voltage drop across this 2 ohm resistor? Anybody? So it will be 0. Why? Because the value voltage drop across the resistor VR equal to, that is voltage drop across the resistor VR equal to, according to Ohm's law, current flow through the resistor into resistance value. Current flow is 0 into 2. What is the value? 0 voltage. So when we are calculating VTH, this resistance will become useless. If I'll redraw the circuit for you guys, I can draw like this. I'm shorting this resistor and I'm connecting that dependent voltage source here. And what they told, this value is twice of Vx. Slowly I will try to catch that value. Okay. So here the battery voltage is given as 10 voltage and the resistance value is given as 2 ohm plus minus Vx. Now if you observe why I am shorting this resistor, because the voltage drop across the resistor will become 0. So while calculating VTH, this resistor is useless. So between the terminals X and Y. Okay, sir. Sir, one more thing. Now you can observe what is the difference between this point and this point? No difference. Actually, அங்க ஒரு resistor இருக்கு. But இப்போ வந்து while calculating VTH, that resistor is useless. Because there is no drop. So, இப்போ இது X னா நம்ம இதையும் இப்போ X னு எடுத்துக்கலாம். If it is Y, then same. This is also Y only. Between X and Y, we have this dependent voltage source. Between X and Y only, we have this dependent voltage source. Between X and Y only, we are measuring the value of VTH. So the conclusion is the value of VTH or the value of this dependent source, that is twice of Vx, both are same. So if we estimated the value of this Vx, then this calculation will be very simple. For that, what I am going to do is, I am simply applying KVL for this loop, only for this loop. Let us see. So I am starting from here, minus 10 voltage, here plus Vx, then here plus twice of Vx equal to 0. Then the net value will become 3 times of Vx equal to 10, or I can say the value of Vx equal to 10 by 3. If I substitute that value here, then it is much easy to calculate the value of VTH. So I can say the value of VTH equal to 2 into 10 by 3, or I can say it will be 20 by 3, or I can say it will be 6.67 approximately. So the value of VTH is simply, I can say what? Approximately 6.67 voltage. That is how we are estimating the value of VTH. See, there will be no different changes. There will be no changes in calculation of VTH. Whether your circuit may have dependent source or your circuit may have independent source, it doesn't matter. Calculating the value of VTH is same. Procedure will be remain same. There is no different approaches. So anyway, finally for the given circuit, we got the we have been calculated the value of VTH, that is equal to 6.67 voltage. Then what is our next target? Our next agenda is we have to estimate the value of RTH. Let us approach with the RTH. So what I am going to do now? Let us take the same circuit, but now what we are going to do? We are going to calculate the value of RTH. I hope many of you might have the procedure, like how to estimate the value of RTH when our circuit is having both the dependent and independent sources. So if you are very well aware of these things, just you can proceed. You don't need to wait for my solution here. You can try it by yourself. Fine, sir. Let us try. Let us try. The second cases, we have to estimate the value of RTH. Okay. So to calculate the value of RTH, what we must do? Let us see. So the given circuit, as usual, we have to identify the load terminal, then remove the load from the load terminal. This procedure will be remain same only. There is no changes. Then while calculating the RTH, whenever your circuit is having dependent source, circuit la எப்பப்பெல்லாம் dependent source இருக்கோ அப்பெல்லாம் நம்ம என்ன பண்ணணும் அப்படின்னா careful observe பண்ணுங்க. I know many of you know this procedure. I know that, but just listen carefully. Okay, circuit la எப்பப்பெல்லாம் dependent source இருக்கோ அப்பெல்லாம் நம்ம என்ன பண்ணணும் அப்படின்னா step number 1, as usual, identify the load, then remove the load from the load terminal, then deactivate all independent sources. Don't forget this point. We are deactivating all independent sources. Deactivate all independent sources. So this word is very important. I am not talking about dependent source. I am only talking about independent source, which will be represented like a battery or by a circle. If you observe in our circuit, there is one independent voltage source. So what shall we do now? Since it is a independent voltage source, we know how to deactivate it. Voltage source will be deactivated by short circuit. So just short circuit this, such that our new circuit will be looks like this. There is one Vx, yes, and that will be going like this, and there is the circuit like this. Right, since this one is short circuited, and here I'm connecting this dependent source like this, X and Y. As usual, this is 2 ohm resistor, this is 2 ohm resistor, and plus or minus this is Vx. Sorry guys, there is some small mistake. Actually, I have taken this question by my own only, so I did a mistake. See, when I have short circuited this, we know this is 2Vx. This one and this one both will become parallel. Then if it is Vx with this polarity, then this also will be same. Right? It should not be different anyway. I have not noticed this. So now I am changing this value in the question itself. Okay. So what I am doing now, I am making it as plus, I am making it as minus. Otherwise, this question will be wrong, right? So just forgive me, I didn't notice that. So this is plus. Let me keep minus. And here I am treating the same value. I am taking same 2Vx. Okay. I am taking same 2Vx. That's all. Now that parallel condition will be satisfied. See, while taking the question, these things should be taken care. Fine. In examination, you won't face this issue. Don't be bothered, because they will clearly, after putting the solution, they will cross check whether everything is fine in the given circuit or not. They will make the circuits based on practical applications only, so you don't need to be bothered. Okay. Fine, sir. Let us continue. After deactivating all independent source, what is the next step? Connect one more exciter from the load terminal, which is having the value of VDC, and we all know our assumption is it will going to drive the current as IDC. Finally, we have to estimate the value of RTH by taking the ratio between this VDC and IDC. So what is the conclusion? எப்பப்பெல்லாம் சர்க்யூட்ல டிபெண்டன்ட் சோர்சஸ் ப்ரெசென்ட் ஆகுதோ அப்பெல்லாம் நீங்க என்ன பண்ணணும், இண்டிபெண்டன்ட் சோர்சஸ் எல்லாத்தையும் டீஆக்டிவேட் பண்ணிட்டு எந்த இடத்துல நம்ம வந்து லோடை ரிமூவ் பண்றோமோ அந்த இடத்துல பேட்டரியை கனெக்ட் பண்ணணும். அந்த கனெக்ட் பண்ற பேட்டரியோட வோல்டேஜுக்கு பேர் வந்து விடிசி. அது சர்க்யூட்டுக்கு சப்ளை பண்ற கரண்டோட வேல்யூ வந்து ஐடிசி. அடுத்து நீங்க என்ன பண்றீங்கன்னா, சிம்பிளா உங்களுக்கு இதுக்கு ஆன்சர் வரணும் அப்படின்னா, நீங்க பேட்டரியை கனெக்ட் பண்ணதுக்கு அப்புறம் அதுக்கு நேரல இருக்க நோடை சூஸ் பண்ணி அந்த இடத்துல நோடல் அப்ளை பண்ணுங்க. You will get the answer in one nodal derivation. So if I'll apply nodal here, what will happen, sir? We all know, see, this is at this junction, the reflected voltage value is twice of Vx. We know how it is twice of Vx. Have you noticed or not? See there, there is one voltage that is directly connected at this junction. This 2Vx is directly connected at this junction or not? See there, this 2Vx, where it is near to this junction only. So what is the conclusion? Since we know this is ground point and here we have 2Vx and its positive polarity is reflected at this junction, so the same 2Vx will appear at this junction also. So the conclusion is the voltage at this point is 2Vx. According to nodal, selected node is the superior one and that will going to deliver the current for the entire circuit. Let us make it as I1, I2, I3. Fine, sir. Now, while applying nodal analysis, we know the first step is KCL. According to KCL, algebraic sum of all outgoing current will be equal to 0, because while applying nodal, there will be no incoming current. Chalo, let us write the expression for this all people. I hope even these things are not required. We can simply solve this question. Guys, let me do one thing. See, this is taking little bit lengthy. I don't want to apply nodal. Again, I have to solve, and I don't direct I1 expression எழுத முடியாது. Again, I have to bring one more relation. So let me go with some other theorem. What I will do is, okay, let us apply KVL for this loop. Okay, apply KVL. Yeah, I found that. That is simple only. Minus VDC. And what is the voltage drop here? It will be, see, IDC current வந்து எப்படி போயிட்டு இருக்கு பாருங்க. It is towards like this. Resistor is a passive element. Current entering point plus leaving point is minus. So current entering point plus what is the voltage drop across the 2 ohm resistor? Resistor value into current flow through the resistor, twice of IDC. So 2 times of IDC. Then here this is positive plate plus where we have the voltage 2Vx equal to 0. Now we have to bring the relation between Vx, IDC, VDC, right? That is our next target. Otherwise, we cannot calculate the value of RTH. How to do this? Just to think. So here I am having twice of Vx, here I am having VDC, and the current flow through this branch is IDC. Sir, how to bring the relation? Let me do it. See, there is one resistor, 2 ohm resistor. Current IDC is going like this. If you see it at this terminal, we have the value of plus VDC. At this terminal, we have the value of twice of Vx. Correct? This is the current flow in this branch. Now, can you please write the expression IDC in another format? IDC can also be written as voltage drop across this 2 ohm resistor. Voltage drop எப்படி calculate பண்ணுவீங்க? VDC minus 2 times of Vx divided by resistance value. So from this, if you estimated the value of 2Vx, what you will get? We can also write this expression as twice of IDC, yes, equal to VDC minus 2Vx. Right, so this is the alternative way to write the expression. Yes, sir. So from this, what I can say? From this, what I can say is 2 times of IDC minus VDC equal to minus 2Vx. Yes. So from this, what I can say? Again, you have to pass this minus to this side. So Vx will become IDC, but minus IDC, 2 getting cancelled. It will be, sorry, plus VDC by 2. That is the value of Vx. So now you can substitute that value here, right? One second. I think in both of these cases we got the same result, right? 1 minute, guys. I think if you substitute, the net value will become 0. 1 minute. Because in both cases we got the same result, no? What we found out, whatever, இப்போ find பண்ணிருக்கோம் இல்லையா, அந்த Vx equation substitute பண்ணீங்கன்னா again we are getting the same expression only. See, what is the difference between this equation and that equation? Both are same. What is the difference between this one and this one? Same only. If we substitute Vx here, I hope the net value will become 0 only again. So we have to replace this Vx in terms of either VDC or IDC. That is our target. So if you do like that, then what will happen is it is pretty simple to estimate the value of RTH. So that is our agenda. So if we do like that, we will get the answer finally. So what shall we do? Okay, let me do one thing. You will treat this one as equation number 1, and I will apply nodal at that point, because here I am not getting this solution. Now see, you have to think. It will happen naturally, no issues. But let us apply nodal at this point as usual already. So there are 3 nodes: I1, I2, I3 equal to 0. So see, I am treating this one is I1, let us take, and let us take this is I2, and let us take this is I3. There are 3 branches. So current flow for this expression in the branch can I write minus IDC? Because you know on the branch already our current வந்துட்டு இருக்கு இல்லையா, that current is opposite to my direction, so I am putting minus IDC. Plus I2 is current flow through 2Vx. இப்போதைக்கு அது எதுவும் நம்ம பண்ண முடியாது, I am just keeping as it is, plus I3. Let us write the expression for I3. What about the value of I3? I3 is current flow through this branch. And we know in this branch, the voltage drop across the resistor is 2Vx. Already we know directly we can write 2Vx divided by resistance, so equal to 0. So from this we can write the expression for I2. Yes sir, that is very simple. right? So from this what I can say is the value of I2 equal to IDC minus 2Vx by 2. That is the value of I2. So this I2 is nothing but the current flow through this what I can say 2Vx voltage source. Yes sir, that is exactly correct. Okay. Further what we can do, now we have to bring the relation between this expression and this expression. Already we have the relation between Vx, IDC, Vx. And again we have the relation between IDC, 2Vx and here I2. So what shall we do now? We cannot substitute this value over there. I think they have done some confusion in this question. So what can we do? We can't substitute this I2 here, right? Just think or take few minutes. If I'll substitute that value over there, what will happen? It will be twice of IDC. Again, we will get RE. Once again, it will be approaching to 0 only. Nothing will change. So, I think they did some confusion in the question. They made some mistake somewhere while taking the question itself. Sure. So, I'm leaving this question as of now. I don't want to waste my time. You can try it by yourself, and if you are getting any answer, please drop your answer. So here I hope maybe I made a mistake. Please cross check once, or otherwise the question maker made it some mistakes. Let me ask them to check it once. Okay, fine. So let us move ahead with the second question. Let me draw the next question. You can try that question. Okay, don't leave it. But here I can't wait and I can't try again and again. It will spoil our time. So let me take the next question and let us try that one. So the next question, they are given on voltage source. Let me give that value. Here they are given the value of resistor. With this, in this case, they are given a current source. Okay. So this is the value of current source. I think in the last question they made some mistake in the question because it is very simple. Dependent source வரும்போது questions வந்து நம்ம ஈஸியாக சால்வ் பண்ணிடலாம். சப்போஸ் கொஸ்டின்ல வந்து ஏதாச்சும் கரெக்டான இதில் வந்து எடுக்கல அப்படின்னா this problem will occur. Let me cross check in my free time and I will update. Don't worry. So this is the given circuit and they named this terminal as A to B. As usual, we have to calculate the value of VTH and RTH for the given circuit. Circuit is very simple, right? So you can apply as usual. See, while calculating VTH, what is the procedure? Identify the load terminal, remove the load from the load terminal, then find out the voltage across the load terminal. So here we have to calculate the voltage across VAB. So VAB will be considered as VTH. We know Thevenin voltage is also considered as a open circuit voltage. You know the reason for that. And the next thing is, let us see, if you observe this is A, then can I mark this one also A? If this is B, can I mark this one also B? Nothing, both points are same points only, there is no big difference. So now our target is we have to calculate the potential difference between these two terminals, or we can say simply we have to identify the voltage drop across this current source. Am I right, sir? Yes, of course, exactly, we are correct. There is no mistakes. Now, my question is, since we all know this circuit is open circuit, yes, sir, this circuit is open circuit. When the circuit is open circuit, then what I can say, this value is going to be 0 ampere. Yes, this current value is going to be 0 ampere. So what can you say now? So if this current value is 0, see, let us apply KCL at this junction. Let's see what will happen. If I'll apply KCL, incoming current is I1, incoming current is 99 I1, then what is the current, outgoing current at this junction? Sir, I1, that is incoming, plus 99 times of I1, that is also incoming. So 100 I1 is coming in, but here unfortunately the outgoing current is 0 ampere. We know it is 0 ampere. Why? Because this terminal is open circuit. Open circuit will offer infinite value of resistance. When resistance approaching infinity, obviously open circuit current will become 0 ampere. So that current will be 0. So I can say incoming current is I1 plus 99 I1, whereas outgoing current equal to 0. Then reduce this expression. 99 plus 99 times of I1 plus I1 will be 100 times of I1 equal to 0. So I1 equal to 0 by 100, or I can say 0 ampere. So we found the value of I1. If I'll substitute here, then what will happen? Since I1 is 0 ampere in this circuit, if I1 is 0, if you redraw the circuit, what will happen? Just to focus, here we have 1 voltage source. Since here they only told the value of I1 is 0. But here we have the resistance. Since if I1 is 0, 99 into 0 is 0. So the value of this current source is 0 ampere. So we can open circuit that current source. We can open circuit. So here only we are calculating Thevenin. Since this current value is 0, what is the voltage drop across the 1 kilo ohm resistor? That is also 0. So voltage 0 means we can short it. So what is the final conclusion? Finally, we don't have, see, simply this positive plate is connected here, this negative plate is connected across the open circuit terminal, that is VTH. So the value of VTH equal to 1 voltage for the given circuit. That's all. I hope you got it. So the value of Thevenin voltage equal to 1 voltage. Finish. Now let us keep our attention with the next one. What is the next question? We have to estimate the value of RTH also. But as I already told you, whenever our circuit is having dependent source, then how to calculate the value of RTH? Let us keep our attention with the RTH calculation. Okay, for the given circuit, let us keep our attention with the RTH. 1 minute, so let me close this. Fine, sir. Sir, how to calculate RTH? Step number 1, identify the load terminal. Step number 2, remove the load from the load terminal. These two things already done by the question taker. Already avangale load வந்து remove பண்ணிட்டாங்க. Step number 3, deactivate all independent sources. If it is the voltage source, then we have to short circuit. Then connect one external exciter with the value of VDC and assume that the current delivered by that external derivative is IDC. Then what I told, choose the nearest node, apply nodal. Sir, இந்த மெத்தட் நீங்க கரெக்டா ஃபாலோ பண்ணுங்க, கரெக்டா ஆன்சர் வரும். சர்க்யூட்ல டிபெண்டன்ட் சோர்ஸ் இருந்தது அப்படின்னா ஐடென்டிஃபை தி லோட் டெர்மினல், remove the load from the load terminal, then connect this exciter voltage with the current IDC VDC. Then அதுக்கு நேரர்ல அந்த நீங்க கனெக்ட் பண்ற எக்ஸைட்டருக்கு நேரர்ல இருக்க நோட சூஸ் பண்ணி அப்ளை தி நோடு. கரெக்டா ஆன்சர் வந்துரும். லாஸ்ட் क्वेश्चनல ஏதோ மிஸ்டேக் இருக்கு, that's why we are not getting the answer. So let us assume this current is I1, let us assume this current is I2, let us assume this current is I3. So while applying nodal, we know nodal is a superior node and that will going to deliver the current for the entire circuit. We know that basic approach, basic knowledge we are having. So with that we can figure out this value. So what I can say is, let us see how to calculate the value of RTH. Just apply nodal and according to nodal analysis, I1 plus I2 plus I3 equal to 0, first one. So what is the value of I1? I1 in this branch already we have a current, that current is coming against the direction of our nodal assumption, that will be minus IDC. Then I2 is current flow through this branch, but already current is coming from that current is minus 19 and I1. Why? Because the direction of the current is opposite to my assumption. Again I3 also minus I1 only. Why? Because that current direction is opposite to my assumption. Sir, to calculate the value of RTH, you must bring the relation between VDC and IDC. But here what type of expression we got? Minus 19 and I1 minus I1 will be 100 times of I1. So I can say minus IDC minus 100 times of I1 equal to 0, or I can say minus IDC equal to 100 times of I1. So from this what we can say, what all we can say is the value of I1 equal to minus IDC by 100. So we can treat this one as equation number 1. So we brought the relation between I1 versus IDC, but what is our agenda? We should bring the relation between VDC versus IDC. That is our next target. Okay, sir, fine. Now what we can see is, if you observe the circuit carefully, that is very simple. See, there is one resistor and here we have the current source and that voltage source is already deactivated, and we have connected the external exciter here, and this is IDC. Here 99 types of I1 is going. This I1 is coming like this. This is 2 ohm resistor. So tell me whether these three branches are connected in parallel or not. Exactly, sir. If it is VDC with this polarity, then same voltage will appear here or not? I hope same. Then same voltage will appear here also? Yes, sir. VDC only. But if you observe, according to the direction of this I1, we can write this voltage drop is 2 times of I1 by considering this terminal is plus, this terminal is minus. Because see, this I1 is traveling in this direction. For the resistor, current entering point is plus, leaving point is minus. But according to the output polarity, according to this polarity, it should be here we have to keep plus, here we have to keep the minus. If you observe, so the resistor drop can be written in two way. 2I1 equal to minus VDC. Why I am putting minus? Because both the polarities are opposite to each other in the resistor. So from this what we found is I1 can be replaced by minus VDC by 2. Okay, let us substitute this I1 here such that it will become minus VDC by 2 equal to minus IDC by 100. So minus minus getting cancelled, 50 times of 2 is 100. So from this what I can say, we know the value of RTH equal to VDC whole divided by IDC. So pass this VDC to the left hand side. From this we can say 1 by 50 ohm is the value of resistance for the given circuit. Sir, I hopefully I won't made any numerical mistakes. If I do any mistakes, you please correct it by yourself. Okay. So finally we got the value of VTH and ITH. I hope now you got the clear idea how to calculate the value of VTH and ITH, sorry RTH when dependent sources given to this given in the circuit. Sure. For your better understanding, let me take one more circuit and I will demonstrate how to do that. So the given it is there is one more one dependent source. I'm drawing it again here, and it is having some resistance. And here they are given one more resistance value, that is 2 kilo ohm. And here what they did is they kept one voltage source. I hope this is previous year GATE or IES question. Somewhere here they have connected the value of load resistance RL. Now let me keep all the, let us assign all the values given by them. They are given, this is 5 voltage they are writing, 2 kilo ohm resistor. This is also 2 kilo ohm, and this resistance value is 1 kilo ohm. This polarity is plus minus 3 times of VAB, and they marked this one is A and they marked this one is B. And one more thing, they in the question it is given that this load resistance is already removed. You don't need to remove, themselves they are removing it. They are telling that this load resistance is already removed. Fine, sir. Now the question is, as usual, we have to estimate the value of VTH and ITH. So you know how to calculate the value of VTH and RTH, not ITH, RTH. Sorry guys. So the question number 1, how to calculate the value of VTH? VTH is nothing but voltage drop across the terminals A and B. That is open circuit voltage. If this terminal is VA, then this terminal also will be A. If this terminal is B, then this terminal also will be B. So the potential difference between these two terminals means voltage drop across the 1 kilo ohm resistor is nothing but VTH. Yes, sir, of course. So to calculate the value of VTH, what my suggestion is, I am willing to apply nodal at this point. According to nodal, selected node is the superior one, and that will going to deliver the current for the entire circuit. I am calling this voltage is VP, nodal voltage. So let us apply and write the expression. So there are three expressions, I1 plus I2 plus I3. Algebraic sum of all outgoing current will be equal to 0, because while applying nodal there will be no incoming current. Now can you please write the expression for I1? So since this branch is open circuit, this current will be 0. So this I1 will come here and then it will be diverted through this resistor and then come back. Now, how will you write the expression? Now, what all you guys will do is there will be a confusion for you guys. Sir, இங்க ஒரு voltage source இருக்கு, இங்க ஒரு voltage இருக்கு VP ன்னு சொல்லிட்டு, இது எப்படி சார் நம்ம இந்த resistor இருக்க drop find பண்றது? One thing you have to understand. You know this voltage source and the resistor both are connected in series. How? See the current whatever that you are supplying here, that current will be coming here only without changes. So இது எதுல நடக்கும்? Only in series circuit. So, in series circuit, by interchanging the position of the elements, you cannot change the property. So, I'm just asking you, what is the difference between first circuit and the second circuit? Tell me. I'm keeping plus minus 3 times of VAB. I'm keeping same plus minus 3 times of VAB. And here I am keeping, let us take 2 kilo ohm resistor. Here also I am keeping same 2 kilo ohm resistor. Let us take at this junction I am having 10 voltage. Let us take at this junction it is connected at the ground, I am having 0 voltage. Let us take at this junction I am having 10 voltage, and let us take this is connected at the ground and assume this voltage is 0 voltage. Now my question is, what is the voltage drop in the first case? What is the voltage across the 2 kilo ohm resistor in the first case, and what is the voltage drop across the 2 kilo ohm resistor in the second case? Can you please demonstrate? Nothing will happen. See, in the first case, just they have interchanged the position of the resistor and the voltage source, but you cannot change the property. How you have to write is, out of this 10 voltage. So if you have any doubts, whenever you are finding the doubts like this, you can interchange these positions like this. In the morning interchange பண்ணிட்டு, then see, according to nodal assumption, நம்மளோட assumption படி current is going from, so நம்ம வந்து 10 voltage எடுத்துக்கலாம். Given questionல I was taking VP, I am writing in the same expression. This is I1. How will you write the expression? This I1 can be written as VP minus, here this positive plate is connected with the resistor. So 3 times of VAB divided by 2 kilo ohm equal to 0. Sorry, not equal to 0. This is the expression for I1. இதிலே நீங்க இப்படி தான் எழுதணும். So whenever you are having the resistor with the voltage source, this is the expression. So by interchanging, அவங்க என்ன பண்ணிருக்காங்கன்னா, இந்த voltage source resistor interchange பண்ணிருக்காங்க. It will not affect the circuit, don't be bothered. So I1 can be simply written as VP minus 3 times of VAB divided by, in our case, that is 1 kilo ohm, plus, how will you write the expression for I2? I2 is here. So here we have VP, here we have 0 voltage. IP can be written as VP minus 0 divided by 2 kilo ohm resistor. I3, I3 is current flow through this branch, but here in this terminal we have the VP resistance, in this terminal we have the positive plate with the 5 voltage. So this can be written as VP minus 5 divided by 2 kilo ohm resistor equal to 0. Now, how will you reduce this expression? See, I am multiplying it by numerator, and the denominator I am multiplying it by 2, such that all the denominator values will become 2 kilo ohm. We can directly add the numerator. If you add 2 times of VP, again VP, again VP. So, I will get 4 times of VP minus 2 into 3 will become 6 times of VAB, and this minus 5, I can pass this to the right side, it will become plus 5. So we got the relation between VP and 6 times of, that is VP and VAB. We all know VAB is nothing but VTH. So how it can be VTH? Did you observe to see the voltage that we are measuring VTH is nothing but the voltage across the terminal A and B. So I can say the value of VAB equal to VTH only. இந்த voltage தான் இந்த இடத்துல போட்டிருக்காங்க, இந்த பேட்டரிக்கு அக்ராஸா போட்டிருக்காங்க 3 times of VAB. So I can say VAB equal to VTH only. There is no big difference between them. That is the first conclusion. And the next conclusion is, now see one more thing. So I can write this 1 kilo ohm resistor, across this 1 kilo ohm resistor, shall I write the voltage like this, plus minus VAB? Of course that is correct, that is nothing but VTH. The voltage across VAB is nothing but the voltage across the 1 kilo ohm resistor. So if you apply KVL for this internal loop, you will get one more expression. I am removing this unwanted. stupid things. Okay, so if you apply internal KVL, it will be best helpful for you to understand clearly. So what I'm going to do now, I'm just applying KVL in this branch. Here current entering point plus leaving point is minus, voltage drop will be VP. So it can be written as minus VP, and then it can be written as plus 3 times of VAB, and then again plus VAB equal to 0. From this what I can say, 4 times of VAB equal to VP. So let us substitute that value here. So VP can be replaced by 4 times of VB. Already one more 4 is there. So it can be written as 16 times of VAB minus 6 times of VAB equal to 5. So from this what I can say, VB equal to 16 minus 6 will be 10. 5 by 10 will be 1 by 2, or we can say 0.5 voltage. This is VAB, we can call it as VTH. So what we have done is we found the value of VTH for the given circuit. Again I am repeating, if I do any numerical mistakes, you please correct it by yourself. Don't focus on my solution step by step. You can try it by your own method. Right? There is no standard methods for this kind of questions. Fine, sir. What is our next agenda? Let us keep our attention with the RTH. You know the procedure, right? So I'm just giving the basic clue. Again, what we have to do? First, deactivate the independent source. This voltage source will be deactivated. Then connect on external source. Again, our own VDC. Then here IDC. Now write the nodal at this point as usual. Okay, so while applying nodal, automatically you will get the relation, right? So you have to bring the relation between VDC and IDC. Sir, I hope you can do this. Okay, just to spend some time, try to bring the answer for this question. In this question, one more logic what you have to do is, while applying nodal, you may need to apply super nodal. If you don't have any aware of this, kindly go through our playlist. In circuit theory, I taught you how to do the super nodal. Learn the basics. I am leaving this question because it is super nodal. You have to learn this. Okay, how to calculate the value of RTH. Do it by yourself. Okay, so I hope you all got the complete idea about the Thevenin circuits, right? So here you have to practice some questions right by yourself. So make sure that whether you are trying to bring the same answer, like, but don't follow any publications. You have to go with your own solutions only. Don't follow anyone, such that you will get the clear idea, right? If you blindly follow or memorize someone's solution, it will not help you in circuit theory. I am giving one question as a homework. Take this one. So I am connecting two resistor, and here I am connecting one dependent current source. Here I am connecting one voltage source. So take this one as 2 times of VP, and you can take same voltage here. Take this is 4 ohm. Consider this is also 4 ohm. Treat this one as 20 voltage. Now you can mark these terminals as X and Y. Across X and Y, calculate the value of VTH and RTH. Okay, so you have to do it by yourself. This is all for this lecture. In the next class, we are going to solve problems based on maximum power transfer theorem and one or two questions from Norton's theorem. See, there is no difference between Norton's theorem and Thevenin's theorem. Now, what my question is, tell me there is only minor difference. What is the difference between these two? Anyway, it is very easy. If you know Thevenin's very well, you can easily solve the questions based on Norton. If you are very aware of Norton, then you can solve the problems based on Thevenin's. Just cross check. I will solve one or two problems in the next class. Then we are going to keep our major focus on maximum power transfer theorem. Okay. Do have a small revision on maximum power transfer theorem, such that it will be helpful for you while solving the problems. because that method procedure is very important.